Now that we know how to calculate critical values to set our window, we can actually set our we can start calculating the lowest and the highest proportion values that we expect on our confidence interval. And how will we do that? Well, first of all, this is step 3 in our plan, and that is called do, where we perform the calculations. You're going to see these steps again as we do different tests and intervals. So once we determine a critical value, we can multiply it by the standard deviation to figure out what our width is, how far we're going in each direction. And I have to be careful when I say width. Um, this is called the margin of error, and it only goes from your estimate to the low end and from the estimate to the high end. So a margin of error is actually half the width of your confidence interval. That's how far you're going out to each side. And to calculate it again, it's just your critical value times your standard deviation. Well, to get the lowest value for the confidence interval, we would subtract the margin of error from our value. To get the highest one, we would add it. And your formula chart actually has this on the back, but it's not something you might recognize. So the way it calls it, it says take your statistic, that's our point estimate, plus or minus your critical value, in our case C star, times the standard deviation of the statistic. So that's actually on your math chart, but it doesn't have symbols. Why is that? Because we're not just doing this type of interval, we're doing other intervals, and these statistic might be different. It might not be a proportion, it might be a mean. And we will get into that in another unit. So recall that our goal is to make an estimation of the parameter p, in this case, based on our sample. So the statistic we will use is p hat. We also don't know sigma. I've been using sigma, but if I don't know p, why would I know sigma? But we can estimate it. We're going to use p hat to estimate it. And instead of calling it standard deviation, now it's called standard error. And that's SE with a little p hat on it. The formula in the math chart is for standard deviation is pretty much the same thing. So you won't see a formula with this on it. You're probably going to see a sigma with a p hat. Go ahead and use that, but remember when we're dealing with a sample, it's a standard error, not standard deviation. So like your math chart, it's going to be p hat. Your math chart actually says p, but we have a sample, so we have to use p hat here and there. But we do know the sample size, and we can put that in. Now, because n is in the denominator in the standard error formula, as the sample size increases, our confidence interval is actually going to decrease. So that's what you want to keep in mind. And we can actually calculate, oh, if I a sample 4 times as big, then how much narrower would my confidence interval be? And that, again, you can actually use this relationship here to determine that. Finally, step 4, we have to make some conclusions. You need to make a decision when doing stats. Will you know exactly what's going on? Never. But you do need to be able to make a decision, and you have to be able to interpret your interval, in this case, in context. In fact, we're always using context in statistics. So since we expect C% of the samples to fall within the margin of error of the parameter, we can use this to make a prediction of having captured the parameter with our interval. You're going to see that word capture. Note we do not say that it is the probability that the parameter is in our interval. And why is that? The parameter is like a fixed value. So it's not moving around and like, oh, maybe it's here, maybe it's there. So be very careful with your wording on that. The way you interpret an interval, and this is boilerplate right here. You can write, we are C% confident. So if it's 95%, you put a 95 there. If it's 90%, you put a 90 there. That the interval blank to blank, your low to your high, or it can be your statistic plus or minus your margin of error, captures the parameter in context. So that would be the true proportion of black beads. Now, we will not know if our interval actually captured the parameter, only our confidence level that we captured it. Do not confuse confidence with probability here. Okay.